Welcome to another GC Basic tutorial. This is part 10 for the PICK16F175 chip family. So I'll just let my logo form and then we'll get started. Great, this is part 10, EEPROM operations. So we'll be covering many different ways of using the EEPROM, how we can read and write in a few different ways. So please like and subscribe. I'm in this for the like and subscribes. Let's try and get it just a few more. Thank you very much. So we're going to show some values on the serial terminal. I'm going to show you some more constants as well, things that are available, and constants are useful because you can use them in your own program. So let's get into it. So I'm assuming you've done all these things. You've got the software installed, you've got your programmer working to a 175. I don't care what programmer you use. I do really. Just buy PICKitPlus. You've got some LEDs operating, a potentiometer and a switch. But for this, you need to have your USB TTL converter working. We covered that in a previous tutorial. So the board I've got, so what we're going to do is write out to the EEPROM, but what we're going to be doing is connecting into port C here, C6, I've got my transmit. That's the USART transmit. And that is actually on this diagram here, RC6. That's what I've got it hooked up to. So all the data will come out of there, okay? Now, let's have a quick look at this chip. This chip is a 16 kilobit chip. That means it's got program memory, it's got 4K of RAM, it's got 256 bytes of EEPROM. Other chips in the family have 128, so make sure you get the one you need, okay? And essentially, in the configuration, you can configure the program memory into blocks, into application boot blocks, and what's called SAF block, and we support SAF block in GC Basic, but will we cover that? I think we do later on. But we're talking here about a piece of memory called EEPROM, and it's up in the upper end of memory, and it has some characteristics that I'll peel back. Because EEPROM stands for electronically erasable programmable read-only memory. Big thing, EEPROM, EEPROM. And it stores non-volatile values, very small amount of data, but allowing these bytes to be written to and for long-term storage, and then you can reprogram them. Now, an example would be I have just completed a Lego train track, and I wanted all my parameters to be stored in EEPROM so that I can just edit the EEPROM, save it back to the chip, hit the reset button, and it reprograms the solution. Reference data, that's what I was programming. It's only like 10 bytes, so I don't change the program, I just change the EEPROM, and we'll look how we do that. So I spoke about some of the constants, and really all these constants are available, and they start off with the word as chip, and I'll show you how we get all these. So the program memory, the SAF memory, the EEPROM, and the RAM are all exposed. They're exposed with the word chip in front of them, chip words, chip SAF memory words, EEPROM and RAM. Now these are all documented in the help, but there's another way of getting at all these, and I'll show you that very shortly. So what we're going to do is program the EEPROM in 3 ways. We're actually going to use a subroutine that actually writes out the address, then we're going to read it in. That's called EPWrite and EPRead. And then we're going to create a table in memory, a lookup table. So if you want to put lookup table out there, then you can just change it. You can change it in an editor and write back the EEPROM. You don't have to keep changing your program. And then I'm going to show you a quick method of how you can just write out some test data. So you can just say, here's some test data and just read it back in. So we've got 3 ways of doing it. One uses subroutine, one uses tables, and one is just a block of data that you can it just writes it out as you're programming. So what we're going to do is we're going to hook up the terminal. We're going to make sure that works in terms of the USART, make sure that all works. Then we're going to write out the EEPROM, read it back and see the results. And then we'll do the same using a programmer so we can see the things on the programmer. So we're going to use a couple of things to make sure that we're getting valid results. We're also going to check the chip to see if it's got a particular constant. It's a small little program. It's really interesting and useful to see. And we'll just see those results on the terminal. Let's have a look at the desk cam. Right, what have I got? I've got the chip in here, the 175xxchip, 4 LEDs connected here, but this time, here's the programming cable. This time I've got this serial cable connected to C.6. That was in the diagram, and this is the earth. So look, here it's over here on the right. Look, here is my TTL converter. Nothing to be scared of. Honestly, it's so easy. Just plug it in. I'm just going to plug it into this thing here, and great, that's it working. And what we're going to do, we're going to program the chip and then suck the data down the serial line. It's lost, you won't even see, because it's not important today seeing the chip, okay? So let's go back to my desktop and open up GCStudio by typing GCS, and it will open up the studio for us. And zoom in. I'm just going to select the 16F175xxchip demonstrations, and it opens up the IDE. So I'm going to press the top left-hand icon, the Explorer, and we'll open up all the files. So the one that we're going to look at today is 140. Let's double click. 150, double click, and 160, double click. So I've loaded 3 programs into the IDE, and we'll see how they all sort of come out. So I'm going to shut that window by pressing Control B, and that shuts the list down. So I've got 3 programs loaded. And how do I see the others? So if I take my mouse and I hover at the top, and I have a rotary button in here, I can just rotate backwards and forwards across the programs. So you can have lots of programs loaded. Now remember, I've got it very large on the screen, so typically these tabs will be quite small, but I've made them quite large so you can see them. So I take 140, showing EEPROM data to serial terminal. So what we need to do is open up a serial terminal. Now, have I got on my zoomy camera thing here? We'll put it on the desktop. Okay. Function key F9 will open up the terminal. Another way is function key F4, and type in terminal. And serial terminal, function key F9 is listed. It opens it up, and I can put that over here. Look, here it is. Now it's not going to stay on top, which is a bit of an issue. So what I'm going to do, I am just going to shuffle things around on my desktop so that we've got half the screen on there and the other half of screen. Perfect. Perfect. What have I got? I've got the chip, option explicit. We've already been through those. They're sort of mandatory. I've got the PPS segment. Remember how to put the PPS in. If I delete it, I'll just put it back in. Function key F4, type in PPS, PPS tool, open it up. It will then show you a list of chips. I'm going to zoom in so that you can see it. Too much zoomy there, look. Bring it into view, look, so you can see it. That's my chip selected. There's lots more in here. I am going to select my transmit. I'm going to allocate it to C.6 and add it into my program, and it creates the subroutine for you. I copy it out, copies it into the clipboard, back into the IDE, and I will paste it in the top here, just above that. That's where it was previously. And it puts it in, and it's now connected the USART capability to that particular output. Anything in green is commentary. You can look at it in your leisure. These are constants. The first set of constants here set up the LEDs, a bit of documentation around the hardware, and then these are the 3 settings for the serial, which are essentially, I'll just move that across a little bit. There we go. Which are essentially set the baud rate to 9.6, transmit blocking, very good, and delay. You don't need a delay unless you need a delay. and I don't think you need a delay. So if I just shuffle that across, that's a bit better. I'm just trying to get this screen laid out before I press the enter key. There we go. Now the program itself is quite simple. It's got a do loop. I define some variables with the dimension statement, wait 3 seconds. I only wait 3 seconds so that if you want to connect the terminal in by hand, you can. I've got a do loop, and that do loop, so it's going to do this forever. It's going to put some serial text onto our terminal, and it's going to say EEPROM test and show results. And it's got some carriage return line feeds, and all that is prefaced by HCFprint. Now I'm using the hardware module. You could use the software module, it's up to you. Then there's some sort of display framing, and it's going to create a frame for us so we can see the data. But essentially, what it comes down to is just a few lines of code. So all this is about framing the screen. You can have a look at that in your leisure. But what I want to show you is the write operation. And what we are going to do is write out a for next loop from 0 to 255, which is the size of the EEPROM, a value called outData. And the outData is going to be a random number, and that's in blue. Therefore, there's a function called random. Well, that's interesting. So you're learning that there's great capability in here. And so if you look above that, you've got a for next loop, you've got if statements, you've got other functions like write and hexadecimal values, but we're focused on sending out a random number using EPWrite. And the EPWrite will put it out to an EEPROM address, which is a variable, and that is using the constant that I introduced in the PowerPoint, which is chip EEPROM, which will be set to 256, because it is, that's the chip specification. And it will write it out 0, 1, 2, 3, 4, 5, 6, and it will write up to 255, a whole load of random numbers. And then we're going to read them back with EPRead into a variable called inData. Then we put inData on the screen. Now, it does the next loop and does it all again. So it's going to write something out to the terminal. We got the terminal connected, not quite, because on the terminal window, I'm just going to connect to my USArt. Let me just rescan it to show it. Rescan lot. There is my and connect. In the IDE, press function key F5. It's programming it. One, two, three. There's the data. Now, let me just push that button. We got some noise on the line here. I can see it. That's noise on the line. Oh, there we go. That's a clean run. So what have we got? We got a load of random data in here. Now, how can I prove to you that that's the EEPROM? I'm going to open up PICKitPlus. And here it is. If I'm connected to the programmer, uncheck the program memory and then just read in the EEPROM. And it should, if it's the same as the terminal, it should start 802C8E 2 and F2. Well, for those who can't see it down here, it says 822C8E F2, and it looks just the same because we have written that data out and we've read it back in. So if I just change the program, I'm going to write out the value of 55 hex. I'll program it. I'm going to clear our terminal. And what we should see in here is just 55s, lots of 55s, because you can write out data. You write it out with EPWrite, write it back with 55s. Great, and then I could do the same inside of PICKitPlus, read it back, and it's all 55s. So what's the key in here? EPWrite with an address, send some data, EPRead, an address, and put it into a variable. Very simple. Let me maximize that. So what I want to do is go back to the top of the screen, and we're going to look at 150. Example 150. Look, same header, PPS, same constants, but this time what we're going to do is we're going to create a table, and we're going to write the table out to EEPROM. And tables are useful. You can either do in program memory, but you can actually write them out to EEPROM. And what it does, it uses the function called readTable. You give it a table name. I've called it table test data source. Look, I've got a table down here, and these are reference tables. Table test data. Store it in the data block, and the data block equates to the EEPROM. So I'm saying write out the numbers 1, 2, 3, 4, 5, and 6, and 7, and I can then access that through this readTable function, which says here's the table name, whatever location it is, write, and then put it into a variable. So it goes, this essentially says, go and get from the data table from that position and put the result in some var. And just to prove it to you, I then I overwrite that address. I write out an address using EPWrite. So I can mix and match, but also, if you don't want to use the read table, you can just do this. An EEPROM block. You just say EEPROM test data, give it a name, and what location you want to store that data at. And I'm storing the data of hexadecimal 11, 12, 13, and 14. So let me just program that by hitting function key F5. And I'm not going to display this. I'm just going to go straight into PICKitPlus, and we're going to read in the results straight into here. If I only knew what I was doing, there we go. And it says in here, the table is this block here. It wrote out the values of 1, 2, 3, 4, 5, 6, 7, and there's a prefix byte. And the prefix byte tells the table read function how many bytes are in the function. You can do words as well, so have fun playing with it. Then I said write out the number 55 hex, which it did. And finally, I said at location hexadecimal 20, write out 11, 12, 13, 14 in hexadecimal. It did exactly as programmed. So EPWrite, EPRead, table data, and EEPROM data. Lots of different ways of using EEPROM. And I said I was going to look at some other capabilities. Well, you can use things like this, and that really should be uppercase. Let me just change that to uppercase for you. Transform to uppercase. I'll just change that. What this does, it reads the chip string name back and just confirms things as you expect. Trust me, you can put a hexadecimal file in a chip that was never intended for, but this will just check that it's actually the right chip. So if I press function key F5, we'll go out to the terminal and just see what it says. And then I'll show you where it says the microcontroller program intended for this chip. And there's some logic in there because it's just made sure that the chip here I've hard coded that check. I've said this is only for that chip. Tell me what the chip string, what the chip string is, and if it's not the same, put the error message up, and it would have done. This program is not in the wrong microcontroller, so it would have said something. Now, where did it get all this information from? Well, if you go into PICkinfo, we can have a look, have a hunt round. Function key F4, type in PICkinfo, and here's PICkinfo. If you look at the chip data tab, many of the constants are listed here, and it says here prog, EEPROM, RAM. Is it chip name in here somewhere? Must be name in there somewhere. And if you look over here, look, it says the prog is exposed as chip words. Chip EEPROM, chip RAM, chip IDE, IO, ADC, chip megahertz. There are many constants available so that you can use those in your own program to create some logic. And in here are many different parameters. What you can also do in here is you can actually open up in an instance the setup file for GCBasic. If you type in GCBasic IDE, it will open the chip configuration description from GCBasic. And here it is, it's opened it up. And this is where all the constants and the whole parameters for the whole chip are defined. Please don't be changing this. It's there just in case we need you to do it at some point. But if you wanted to know if a particular register existed, we'll say TMR0, yep, it's defined, it's got a register address, and you can go and check that in the datasheet if you wish. PICinfo is a huge resource for the constants. Back to PowerPoint. So, full screen. Now, enough on that type of stuff. We're going to look at communication protocols. We're going to do some I2C discovery. We're going to go from serial connections like we did with the terminal, but now we're going to use another serial connector connectivity method called I2C, and we're going to do some discovery of devices. Enjoy.